Hey guys, Mr. T here with another video. This one is on probabilities from table data. So, experimental probability we've talked about is probability calculated from experimental data. And experimental data is often displayed in tables. So when you display data in tables, you can use it to calculate the experimental probability of certain events that you've displayed. So the first example we'll do is George plays a game called Fortnite and he keeps a record of the number of wins, victory royales I think it's called, that he achieves each day. The results are in the table below. So 0 wins in a day happen 10 times, 1 win in a day happens 17 times, 2 wins in a day 12 times, etc. So to be able to do probabilities, we need the total number of trials. So question A, state the total number of trials. That's first an important step, and the easiest way to do that is to look at that table, look at the frequency and find a total for it. So there was 10 trials for 0 wins, 15 trials for 1 win, 12 plus 3 plus 1. So you're adding the frequencies together to get a total frequency of 43. Okay? So there was 43 days of trials basically. So A, 43 trials. B, calculate the experimental probability that George will win only 1 game in a day. So probability 1 win is going to be equal to the frequency of the thing that I'm interested in, 1 win in a day, 17 times out of the total of 43. It's going to be 17 divided by 43, with 0.3953 goes on, therefore 0.40 to 2 decimal point probability. So it's around about 40% chance. So he's got a 40% chance experimental probability that he'll win 1 game in a day. Let's do C down here because there's space. Calculate the experimental probability that George will win at least 3 times in a day. So this is important language that you will experience because we're going to have questions that will try to trick you with this language. When I say at least 3, that means I'm happy with 3. That's the least that I'm happy with. So I'm happy with 3 and above wins in a day. So that means I'm concerned with 3 wins and 4 wins. So I need to add those frequencies up. So the probability of at least 3 wins is going to be there were 3 days with 3 wins and there was 1 day with 4 wins, so it's going to be 3 plus 1, 4 on 43. 4 divided by 43 is going to be 0.093, goes on, therefore 0.09, 2 decimal points, therefore it's about a 9% chance of getting at least 3 wins in a day. So that's from that kind of table. That's called a frequency table, and that's the kind of table that you'd be most familiar with at this level. So the second kind of table that we can deal with is a two-way table. Two-way table is a different type of table comparing categorical variables. Again, this info is displayed. The info displayed can be used to find experimental probability. So the example here is we've got Year 9 students in a school asked if they like maths. The results are displayed in the two-way table below. So what a two-way table is if you've got a variable horizontally, a variable vertically, so it's got gender and like and not like, or preference I would say that variable is. And so the intersections tells you when those variables combine. So that's telling you the number of boys that like mathematics is 17, the number of girls that like mathematics is 19, number of boys that don't like it is 8, number of girls that don't like it is 12. So it's pretty self-explanatory to read these tables, but it's important that you experience it. So let's answer these questions. Let's do them here. A, calculate the probability that a randomly selected student is a boy. So here, we're talking about any of the students. If I was to just close my eyes and randomly choose one, what's the chance of it being a boy? So our total number of trials, or the total thing that we're interested in, is all of the students. So we need to work out 17 plus 19 plus 8 plus 12. There was 56 students in total. 56 total students. So the random chance that it's going to be a boy. Now, all we care about is that it's a boy, not whether they like maths or not. So we're not just going to choose either 17 or 18. We need to add those together, because the occurrence or the event that we're interested in is the fact that it's a boy, not the fact that it's a boy that likes maths or doesn't like maths. 25 boys. So probability boy is going to be 25 on 56. 25 divided by 56, 0.45 to 2 decimal points, therefore 45% chance that you randomly select a boy. B, calculate the probability that a randomly selected student is a girl that does not like maths. So there is more to this one. It's a girl and it doesn't like maths. So we're not just considering whether it's a gender or not, like we did before. We're specifically targeting the girls that don't like maths. So 12 girls don't like maths. And what are we selecting from? Then I'm randomly selecting student. So that means I'm selecting from any student. So probability of girl don't like maths is going to be 12 out of 56. 12 divided by 56 is 0.2142. So 21 to 2 decimal points. Therefore, 21% chance. And then C, calculate the probability that a randomly selected boy likes maths. So the two keys here are they like maths and a randomly selected boy. You're not selecting a student, you're selecting a boy. So the total that you're comparing to isn't 56 anymore. You're selecting a boy to start off with. So there's 25 boys that you're selecting from. And how many of them like maths? 17. 17 like maths, 25 boys. So probability boy boy selected from boys, to be specific, likes maths. Because if I was just to say the probability of a boy likes maths, then that's similar to part B. You're selected from all those students. So boy likes maths, you've got 17 like maths out of the 25 boys. 17 divided by 25 is 0.68, therefore a 68% chance that out of the boys, if you select one of them, that they will like maths. So that's just an example of finding experimental probabilities from two different kinds of tables. Hopefully that helps you out, and I'll see you in the next video.